have Satish here. He is CTO of our Kadai. And in today's Java Fest conference, he's wearing multiple hats. He was one of the seeder for Java Fest idea. He is a speaker here. He's top core organizer, also an educator in recession sessions. So, and Satish is known to deliver, serve technology in terms of bhajis and bondas. I'm very eager to see what analogy he's going to give today. Over to you, Satish.
Definitely no bhajis. Bhajis are only for microservice talk. How many of you attended that microservice session? Okay. So it will not be that entertaining. We will do something informative. I'll try to do something informative. Okay. So this talk will go a little randomly only. Same rule, meet up our conference. Stage is different, but the methods are same. Any of you have any doubts, you can ask here, or you can ask after this, or you can ask in any Bangalore jug. We are here to answer your questions only, so don't hesitate to ask any questions if you have any questions. Okay. So this talk is more of a research talk, so I'll go that way. It will not be like another technology or something like that. It will be more, sometimes I need to take some history, stories and all those stuff, so bear with me. And as I keep always saying, history is very important. Whether you are studying in college or you are studying in technology world, history is very important because it's history who gives us problems. And because of that problems, we go and find solutions. And the solutions become technology. So it's always, if you look at even real world, right? People who read history, they will be ruling people, right? Same way. So if you want to rule your technological world, always pay attention to your history. So with that note, I will start with today's talk. So this will be more like a discussion. How many of you part of this digital transformation journey in your company? Okay, so even though we put different names, I would say digital transformation from enterprise side, it's very simple. It's between Java connecting to a relational database. We connected from Java to Oracle and then Java to Postgres, Java to MySQL. Maybe you'll be changing those, but most of the time you'll be, many of the digital transformation projects are around this area. So this area is very important because whether we like it or not, you interacting with the relational database from Java, it's a very common area that you will continue to do even in future, where even though there was no more hype about NoSQL, but at least people are now finding ground with relational databases for their own good. We had a separate talk, we'll go to that in detail later. But one, I just want to keep it again, relational databases are coming back and they are coming back very, very strong. And same way that NoSQL movement happened, now there will be SQL movement also happening. So it's like people go upwards and then they will come down. Same way, people go to monolithic to microservice, now they will come back from microservice to monolithic again. It's called modular monolith. So I just want to keep two things related to frameworks and technologies. Frameworks and technologies, I cannot say something that I say today is valid tomorrow. Not like any human values. Human values, be good, do good, that is always valuable. But with the technology, that's not valuable. We'll go to an example later. And also, your solution depends on the tools that you have. For example, if I want you to travel from here to say Hosur, if you have bicycle, that's a different story. But if you have motorbike, then it's a different story. If you have a car, it's a different story. It's a tool which decides the solutions. So these are all the two facts that we need to consider. Why we consider that, we'll go later. Before we go into the detail, we'll go one by one. So I'll just go with history, what happened with these persistent problems with persistence. So very early days, thanks to Raja. Raja gave that first option here, that is ODBC. Any of you started your career with ODBC? ODBC? Okay, very few. Okay, all senior folks. Okay, so I started with JDBC. Just 1 year later, that's it. So when we started interacting to relational databases from Java, first we had this option of ODBC. On those days, you need to install software to your machine. And then only you will be able to connect your relational database. That is how it all started. Because of that installation, that time there was no cloud. People used to carry CD. They go on site just to insert the CD into the client machine. Just have a star hotel stay for another 1 month or 2 months. Now that on site is no more logistics, right? We just do it everything in the cloud. So this ODBC was at that point in time. But it was quite difficult to install and all those stuff. And then came JDBC. JDBC is actually supposed to serve as portability tool, where you use the same methods to connect to multiple databases. But we need to watch this portability word with JDBC. This portability word you should not confuse with the portability word that you use today in ORM tools. ORM took this portability into a next level, altogether a next level. JDBC gave an option where as a Java programmer you can connect to your database, but still your SQLs are not portable. If you have written some SQL that works in Postgres, it will not work in MySQL. That time even the standard was not there, and that was the problem with that. Then till at that point in time, there was no problem of tools or frameworks. It's all native Java. But then it started with the first set of frameworks. If you are coming from banking industry, most of you are still will be using that. There was connection-based frameworks. The problem with JDBC is, so we gave an interesting terminology. I don't know whether it's a right word or it's a parliamentary word, but he said idiot-proof. JDBC was not idiot-proof in the sense, if you open a connection, you need to properly close the connection also. If you open a result set, you need to close the result set also. Otherwise, you have a lot of nightmare, right? And people are lazy. As we grow, or as we become more technical savvy, we become lazy. That's part of it, right? You have mobile, you become lazy, right? Same way. So people are not doing their work properly, and that's why connection-based utilities came, where you can execute the query and they will take care of opening the connection, closing the connections. Even today in banking system, you can see that there is a strong connect to that connection framework. They are coming back again. I will go to that later. But now with the current generation, so now I'm coming to the current generation. In the current generation, all this that I talked about are not at all an option. You will be either working with an SQL mapper or an ORM. How many of you are working with Spring JDBC or MyBatis? Okay. So you all work with SQL mappers. How many of you are working with Hibernate? Okay. Majority. Okay. Why this is majority, there is a history also. That I will go later. More the history, it will take a lot of time. But between SQL mapper and ORM, SQL mapper takes a side from database. So for example, if database is this side, SQL mapper takes a database side, which means you can execute anything that you want from the database. All that SQL mapper will do is they will map an SQL into a result set. And you can do whatever that the database takes. But the side effect is you still need to write your own query. Now ORM took a different approach. It took a side. It said, I will take a side of Java. So from the Java world, ORM says you map a table to class. You map a row to an instance of an object. Then I will do rest of the things. I will do all the magic. But if you do a lot of magic there, magic will become a black magic that many of you might have experienced, that will go. So now, what you need to understand is, people had no other choice apart from taking a side. So one side, if you are taking an ORM side, always there is it's all about balance in technology. If you gain something, you lose something. It's all about more gains, lesser disadvantages. That is how we make the choices. So with SQL, even today, SQL mappers are coming back now, again strong. The reason being, there are considerable amount of changes that has happened in the industry. So far, of course, beyond this, there was lot of small disruptive things happen. For convenience sake, I have not put it here. I will explain that later of the stage. But consider that these are the majority of reasons why actually digital transformation happened. Now, when I'm talking about digital transformation, I'm just taking two case studies. One is Meta transferred from MySQL 5 to MySQL 8. And another publicly available information, DBS Bank migrated from Oracle to Postgres. Now, one commonality that you see every time somebody migrating from one to another, it's not 1 or 2 days of a job. It's an year-long plan. If you go and look at those white paper, you will understand. Because it cut across multiple teams. So if you are upgrading, you need to go through that pain. That is a usual thing. So our talk is going to be about what are all the pain points that we can avoid from there. That is the idea. Which one? Yeah, I'll come to that. So, mostly, when we talk about our discussions usually in our regular work stops with discussing about frameworks. Angular is best or React is best. Spring is best or Quarkus is best. But I would always recommend you go one level down. Look at the approach. Because it's the approach that decides the framework. So, now we'll go even one level lower. The more that you go into the depth, you will get the future prediction little better. That's the idea. Now I will go even one level down. I started with this. Actually, it's a wrong place of starting. I intentionally started with it. Can someone tell me what is the push factor for, first of all, approach? Changing an approach. Changing an approach, as I told, it will take years. And every company is not going to do it just like that, right? It's going to cost them huge money, huge coordination effort. If they are changing an approach, there should be a valid reason. What would be that reason? Mostly cost, but business. In one general business. It could be security, it could be cost, or whatever it is. For example, we all talk about electronics vehicle is the future. Why are we talking about it now? Because we have drained all our petrol resources already. Now we are talking about electronic. It's not like electronic was not available earlier, right? Electric vehicles are available, right? So it's business who decides that. That is the reality, right? So I will go one level down. We will go to the business-wise what went through in the over this. This is like 15 years, this is what happened. So now we'll go through what happened. When we all started software industry, we were writing projects. Projects in the sense, I will go to, say for example, Big Bazaar, I will write a software for them. I will go to Flipkart, I will write a project for them. So it's all projects. And slow projects were relatively smaller projects. Till that time, this JDBC approach was good. But slowly, projects become bigger. We started working with people like, I'm talking about 2005 or something like that. We had team size of 200, which is very, very common. So larger team size was a very, very, very important factor. Now, if you consider this larger team size, with larger team size, you will not have specialized resources. And that is why ORM came into picture. Because with ORM, once you map it, after that, everything will be taken care by ORM. Right? Then we started doing products. When we started doing products, what was the inherent need from the product is, every product, the customer used to say, in my company, I have bought license of Oracle. In my company, I have bought license of, say, for example, MySQL. So it is the company's license decided the portability requirement, not technology. It's not technology which decided I'm giving portability, come and use it. People don't use that feature as long as they don't need it. The need came because we got into the product culture. And these are all the factors that everyone that you see came into the market. Okay? Now, the reason that I'm considering all this past, it's very, very important because only when you know past, you can predict the future. We'll go to the prediction later because we should not, for example, many people do data science without even doing data engineering. That mistake we will not do. First, we'll do data engineering. We'll get the data in the proper shape, we'll quantify the data, we'll have enough quality data also. Then we'll go. Okay? Now, hope till this much it is clear. It is the business need which got the solutions. Right? So, probably today's business need is a little different. That is what we are going to see at the end. So, now with that, I am just going to consider what are all the things that changed today, because we need to accept that these are all the things that is changed. Then only we can accept that the approach has to be changed. Without that we are preaching approach, nobody is going to look at it, nobody is going to be interested in it. So now there are two things that you can see. You can check the brand new ORM tools that are coming today. There will be a common connect between all the ORM tools. What is that common connect? We will see. So before we go to that, let us consider today's scenario. In today's scenario, I want to just consider three important factors here. Point number one, I think people can see this. So point number one, we started doing SaaS products. We started doing SaaS products. We are still doing products, but we have started doing SaaS products. Now, one question that we need to ask ourselves. When product came into picture, what was the need? Portability was a need. Now, when we are changing from products to SaaS product, is portability still a need or something else is a need? Scalability. At that point in time, as a business, I made a choice. Say, for example, one customer is using Postgres, another customer is using MySQL. So, just to bridge the gap, just to keep both of them happy, I need to compromise on the quality. Now, in SaaS world, who decides the technology stack? It is you as a product owner decides. It's not your customer. Because of that, portability is no longer a case, but rather, how much I can squeeze from my underlying solution is the important factor. So it's all about getting better performance, better security, better features, better maintainability is my intent, not the portability. That is one. Okay? Now, cloud microservices are highly, DevOps are misused word, but I will just take cloud as a very simple example. Cloud is nothing but renting a computer instead of having your own computer. Keep it that way. Keep it that simple. Now we are getting to the cloud era. What change that cloud expects? Robustness, okay. Scalability, okay. But one specific word, maybe I will put another question. Sometimes, right, if you don't get the answer, you go to a different direction, you will find an answer. What is this native compilers do? GraalVM. We all claim that GraalVM is cloud ready, cloud ready. Why we are saying GraalVM is cloud ready? Boot up time, startup time. Okay, why startup time is less? Compile natively. Very good point. Okay, any of you from front end side? React.js, Angular, or you are aware of it? Okay, you are aware of it, that much is sufficient. Now in front end side, something is happening for cloud native. They call it as static site generators. Hugo, Jekyll, what are they doing? All that they do is, whatever rendering that you want to do, they will do it right at the compile time, get it, put it in the CDN. So it's like this. If you have your own machine, you don't bother about startup time, let it take its own time and all those stuff. But when you are paying rent to somebody, you want it to start quickly, use less memory and all those stuff. For that, what people are asking is, whatever that you want to do it at the compile time. No reflection, no runtime optimization. Correct? And that is the place where the native compilation that we see today, GraalVM or static site generator. Now let us come to the Java world. Just look at certain new tools that has come. For example, Dagger 2, or the most popular one would be Dagger 2. There is something called Juke. Juke. How many of you are using Juke? Juke. Okay. J-O-O-Q. Okay. What is the significance in Juke? Type safety. And how is it getting type safety? Whatever that you compile, it will compile and create the code, correct? Yeah. So, very simple logic. People want to create everything, make a parcel and deliver it there. It's like you get the parcel from Swiggy rather than you go to the restaurant and order it. Right? That is what cloud influences us. And the third point, which easily people sometimes overlook at it, and that is what I think the most important point. Evolution of RDBMS. RDBMS has gone through a drastic set of changes. Few years before, RDBMS were strongly questioned for two reasons. Because of their scalability limitations, and point number two, they are very strict. They are structured databases. Because of that, people went away from relational databases. But now, they are coming again to relational databases. What is the two reasons? Two reasons is, point number one, today's relational databases are highly scalable. Whether it is Google's Cloud Spanner or AWS supported Postgres, they all scale themselves. You don't need to put any effort. But the second one is very, very interesting. Now people are saying, I'm going to relational database because they are structured. People went away from relational database because they were structured. People are going to relational database because they are structured. Why is this conflict? Experience, right? So, same way that I can relate is, around 2003, Spring, Hibernate, everybody saying, we are highly XML supported framework. No Java code, it's only XML. After 2005, Spring Boot was not that. Spring and Hibernate changed their approach. They said, no XML, we are completely Java frameworks. Why? Because in 2005 or somewhere, Java 5 came, which brought a feature called annotation, which gave a better way of doing meta programming. Right? That is what I told initially. JPA became a standard after annotation. So it's like the tool that decides, like I told that motorbike example, right? It's a tool that decides. Now, we need to look at the tools. Only when you look at the tool, you will be able to make the possibilities. Okay? Now with all, actually I know that this is a little bit extended introduction. I think it is needed because what we are going to talk about is it needs a different mindset. Now combining these three, what we expect today is, whatever that we want to do it right at the build time. And when we execute it, we need a better performance. We don't want to take a choice. We don't want to take sides like database side or ORM side or something like that. That is the idea. With that note, I will get into this compile time ORMs. There are many compile time ORM. One that I'm showing is a research project that we started at Bangalore Java User Group based on the feedback that we received from Bangalore Java User Group. Consider that SQL component is one of the compile time ORM. There are a lot of other things also. But at the same time, in SQL component, we are doing certain things which we figured out that The modern day compile time ORMs are conveniently escaping, conveniently missing it out, and that we want to incorporate. So these are all the 3 challenges. So these are all, usually these are all my upgrades that you need to consider. Hope everybody agrees. These 3 are not smaller things. This takes years. Correct? Right? Okay. We will see that at the end. Whether it takes years or not, we'll see. Relational databases today, one is that, and then type is safe. So these are all the common frameworks that I explained. All people need control in the compile time itself now. These are all the frameworks. When you find time, go and look at them. Diesel is from Rust side, SQLC is from Go, Juke is from Java. I think this is CGSQL from Meta, the open source written C language. Now there is commonality between all the 4. So they all do the compilations and keep the code right at your compile time. With that, I just want to go through a small demo. After the demo, we will continue again. But I just want to show how the developer experience will be once we get into these kind of frameworks. Over to you, Haripriya.
Hi all. So we are going to look at a demo where I have a small application. It's kind of a book my show kind of an application where we'll be booking shows, viewing list of movies, or selecting something. So here, what I am having here is like simple creds alone, not much of that. So here we are going to look about this SQL compiler, which I have with me. So before going on that, what I am doing is I'll be adding this SQL compiler to my pom.xml, and this is the compiler Maven dependency. So after that, and this is my data dictionary where I'm representing my database connectivity rules, and what are all the, for example, the mapping logic I'll be representing here. So for example, when I'm going and compiling my database, and I sometimes need to give certain rules where, for example, if I need to exclude audition files or read-only fields, something like that. So I can add them here. So this one tells the insertion map where I'm specifying that the created date must always be equal to the current timestamp. And again, another rule is for update map where the modified date must be again the current timestamp. So this is my data dictionary, and again, this specifies our database connectivities. So with this compiler, what will happen is, once I build my application, and what will happen is that in my target folder, all my model classes, repositories, and SQL DSL files will be auto-generated, and with the help of the compiler. So that makes is that the size of the code is generally being decreased. With the help of this, you can see that I've built my code, and you can find that the model file is being generated, and the movie manager is also being generated. This movie manager is the one file which includes all the SQL operating queries and things. So these are all being generated with the help of the SQL components compiler. Okay. So after building my application, I'm just going to start with my basic applications here. So this is the application file where I just have 2 statements. One is a simple insert, and that which returns what record is being inserted here. And again, I have a list of movies in a CSV format, and I'm inserting them as a list of data. Just 2 methods here, nothing more than that. Okay. So here what happens is, my compiler provides me with the facility of fluent SQL DSL kind of coding, that is more of declarative style of coding. So that which makes us the coding a bit easy for the developers. So also this compiler provides us type safety. For example, this is an insert statement where the title is of data type string, and it won't allow me to enter anything in other data types. This is a small example for that. So this throws me an error. So this provides with type safety here. And also, this compiler gives us optimized mapping, and all these operations are based on the flow of our data type. So this is what is happening. So after running this code, let me debug it, and I'll show you. Before that, this is the movie manager file that is being compiled with the help of our SQL compiler. And so this is the movie manager file. This file consists of all the SQL queries which are being created. So here is the query for insertion, and similarly here is a query for returning, and here is the query for all these things. See, these are all the queries, or these file is being compiled and generated by our SQL components compiler. So that's it. So I think after debugging, so here I was SOut. I did an SOut for the select query here, and this one, as it is an declarative kind of coding, what I can do is I can get suggestions once I have this. So here, these are all the fields which I have in my movie SQLs. So this is if I'm going to check a query or check the IDs, I can go have it, and these are the suggestions being provided for that. So either an ID can be greater than, or it can be equal to, or greater than or equal to, and these are all the options which my compiler is providing me. So with this, here I'm just debugging this select query here. So you can find I have picked for the movies which are directed by James Cameron, and I have just 2 records of that. So this is what has been displayed here once I debug it. So this is done with the help of SQL components compiler. So that's it with the demo. Thank you.
Thanks, Haripriya. Hello. 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 Thanks, Haripriya. So this talk is not about the full features of SQL components or compile time things. This talk is about something that we need to see after that. But before I go to that, have you all noticed what is the change that has happened now, right? It's all being done at the compile time. And the type safety, I just want to go again with the type safety here. So if you look at it, the moment you do a compiler, the code that is being generated here, it is not depending on any library the moment the compilation is done. This is why I related this with static site generators, right? There is no JavaScript here, it's all HTML. Same way. So one that automatically will happen is performance. You still have the type safety that you experience with your JPA. In fact, the type safety now goes even 1 bit extra. With Hibernate, how do you write custom queries? JQL, but you will give a string. We'll give a freestyle string, right? Now just let us just look at this SQL that is being generated here. So this is that SQL, right? Now 2 things that you will notice here is every time that you select one, that if you send a wrong type, for example, if you don't give short, it will not allow you, right? Because it's a short. Similarly, when you are doing a select query, if you observe this, here this rating is what? It's a number. If you put a dot, you will see greater than, less than, greater than equal to, less than equal to. If this is a string, what are the operations that is allowed for string in querying? Either equal to or like. That is all that you will see. So this and all, once you use it, you will know. But let us go to the actual part of our talk. Now, one thing that I told, it is a solution that decides how much of a problem that I can solve. Now I'm just going back to this upgrades problems that I had. with this compile time ORMs, do you guys see a logical place where we can solve our upgrade problem a little better? Any guess? And I think this is one point that even not other compile time ORMs are claiming, but it's actually the possibility, but that has to be explored. Okay. Now, when you are doing the compile time generation, what are the things this compiler considered so far? Two things. One is your type. That is what it validated. Other one is the sequence of operation. Sequence of operation, technically it is nothing but a builder pattern. So it uses a builder pattern for SQL. That much it verified. Let us just take this one level higher. So now whatever that Haripriya showed, you see this returning statement here. Why returning is required is, in a typical enterprise application, every time you save something, what do you expect in return? Every time you save something, what do you expect in return? The record that is being created, right? Usually that is done with two queries in a typical way. One is the query that is going for insert statement. I hope all of you can see this. My screen is very small. Okay, you can see it. So another thing is, another query that is being fired here. What is this query is used for? What is this query is used for? To get the record. I inserted it, I am getting the record. Okay. Now I'm not going to make any code change here, but my company decided that I'm using little old version of what is it? Postgres. I'm using 10. So now my company is saying, can you upgrade to 11? Between 10 to 11, Postgres added something called returning class. What is a returning class will do? Returning class in Postgres. So Postgres added, it's now standard feature in SQL itself. This is being part of Oracle also now. This is added with multiple databases now. So with returning class, when you do an insert, you can also say, see, I am doing an insert, give me these items returned in return. Okay? Now can you connect where the optimization can be explored? In our case, returning case, instead of two queries, we can make it as one. But for that, the developer doesn't need to put any efforts, because with SQL, not just SQL components, compile time ORMs, you are not coding, you are doing metacoding. All the coding that you are giving is your data dictionary file. That is this mapping and all those stuff. So now all that I did is I did not make any single line of change. All that I did is I upgraded my environment. Now I am just going to repackage it. Now when I am doing repackaging, what will happen? It will compile. It will generate the code. Now we have added this intelligence to the compiler, where the compiler is checking which version of Java that your program is running, which version of Postgres your program is running. That intelligence that compiler will have. With that intelligence, so when compiler generates the code, let us look at the returning now. Let us look at what has been generated for returning. Okay, I thought it will not work, demo worked. What do you see? Yeah, we changed the database version, right? Okay. What was the problem? Okay. Let us look at the Docker compare file. Okay, my infrastructure is not updated. Thanks, Haripriya. So I stopped it, removed it. Now I am starting it again. So my infrastructure is now changed to Postgres 11. Now I do all that I ask is now in clean package. Now this gets us a very interesting problem that you don't even consider it's a problem. Every time some library changed, as a framework owner, I need to balance it, right? I will say Hibernate supports minimum version is 11, minimum version is 17. And if Say Dhananjay is using 19, I am using 17. Both Dhananjay and myself will get the same code, which is not fair. With compile time ORMs, we get that even that problem solved, because when the compiler compiles, it understands what Dhananjay's compiler will do, what is that environment that Dhananjay has, what is the environment that I have. With that, now let us just look at the new one, which I have not put any effort. It's not my code, it's not our code, by the way. Now you look at it. Do you see the improvement here? 2 improvements. Point number 1, if you look at your query, at the end, you are having returning all the records. So my returning is already coming. Now it is no longer an update. It's no longer update. So I will get my result set directly. Here you see, I will get my result set directly from this one. This is just one. But the point here is, with this compile time ORM, where we are trying to go is write once, update every time you run a build. It's not like update whenever there is a time comes, whenever the need comes. We have the right to upgrade whenever the infrastructure teams is upgrading, either a JVM or your underlying database, we have the right to upgrade. And that is the place where these technologies are taking us. There are some interesting other possibility with transactions and all those stuff, because with this kind of flexibility, we can rethink our old problems in altogether a different manner. And that is still to be explored. Hopefully, this area will be explored further, and then we will see the benefit of this technology also in future. That is the idea. So hope this was clear and it was informative. Thanks guys. Any questions? Please, you can contact me anytime, or I will be available in the stalls. Thanks.
Thanks, Satish and Haripriya.